Alright, hello, this is our city project, and here we go. So background, this is a map of the area, the location, we did some research. It's Lake Tumba in the Democratic Republic of Congo. Just to get an idea about like what other kinds of cities were, we found the closest large city is Mabandaka, which has a population of 800,000 people or so. And another thing we looked up was the climate. And so, here's climate data for Mabondaga. As you can see, the temperatures are pretty consistent, pretty hot. It's similar to July in Ohio, except it's year-round. And they get about 64 inches of rain compared to 40 inches annually. And then economically, their GDP per capita is $729 per year on average per person, which is second to last of all the countries on the list, or depending on what list you look at. And so it says that much of the nation's economic activity takes place in the informal sector and is not counted in official GDP estimates. And so that definitely has an impact on the city. If you look, these are pictures of Mabandaka, and so it gets you an idea. This is it's a really large city, but it doesn't really look like a city. It just kind of looks like a town. And so that influenced our process. We realized the needs of a poor, undeveloped city, or I guess the city in a poor, undeveloped country is a lot different than, say, like New York. And so we were thinking we would have big, wide roads, maybe out of dirt, and we'd have it be pedestrian and bike friendly, and we don't need skyscrapers, anything crazy. So let's see. And now transportation.
Now for transportation, we wanted to take an eco-friendly take on this, so we have no automobiles, so that we'll only be using our railway electrification system for our transportation system, and this will get anyone wherever they need to be, or within like a block or two of that location, and we'll have the electricity supplied from the nearby Flywheel energy plant, which is near the windmill offshore plant. The system will use a 750 volt DC railway electrification system, which is most common in like urban cities. And there will be no automobiles except for emergency medical system vehicles, but they'll just use dirt roads that are already on the city. Now on to electricity.
Alright, so here's electricity. Just some background on Congo's situation. Only 9% of Congo's 70 million people have access to electricity, and it's about 30% in urban areas and 1% in rural areas. And so if you assume that people use 3 times as much energy in rural areas and you do the math, basically all of the energy is going to cities. And so I took the energy per capita of Congo and did some math and basically figured out, long story short, that if we were to use wind turbines, which we decided on because it's eco-friendly and they're cheap relatively compared to other forms of renewable energy, and so we just decided to use wind turbines. And so doing the math, it came out to we would need 4 up to 14 turbines when we went from 25,000 people up to 100,000 people, and that we can easily add more wind turbines if our estimates are a little bit off. The general system, however, for transmitting the power stays the same. Here's a diagram for what the power system would look like, and on the right here is a picture of the Flywheel energy storage system that we're also using to help the wind power, which can be finicky during the day, keep with peak periods of when people need power. And so here's the same system implemented in our city. It shows the offshore turbines, wind turbines that we're going to have, and then the storage here, and then it's pretty self-explanatory, and we didn't draw all the complete power poles everywhere because it's kind of the same thing. And I think that's it for electricity. So now on to city layout, now sanitary water.
Okay, so we modeled our city partly off of Dublin, Ohio, our hometown, and we use 5.9 million gallons a day for 40,000 people. So that's 140 gallons per person per day. So that would mean our city at peak would need 14 million gallons a day. So we're going to use our water from the Ubangi River, which has 2.9 million gallons of water per second flowing through it. So that will be plenty and more than cover what we need. So we'll have a reservoir next to the water for purification plant to like hold water there, and there will be 5 water towers distributed through the city. Now for our sewage system, we'll have separate storm and sanitary sewers. The storm sewers will be prevention for like street flooding or home flooding, and they'll lead directly into Lac Tumba. And our sanitary sewers will take all the population's wastewater and sends it to a sewage treatment plant near the bottom of the city by the shore. And there it'll separate the water and the waste and convert the waste into fertilizer, which will be transported to our farmland. And the water will also be deposited into the lake. And that, now on to our city layout.
All right, so here you can see the main, where the main center of our city is. It's on this little area, and so not all the city population will live here. There will also be people around here, farms and stuff, but as for the main city, it's here. And as it expands from 25,000, which is about this whole area here, it can expand up and to the right in this area to get to 100,000 people. And I guess as you saw earlier with our tram system, we've only made it for the center, but it's very easy to add modules onto it to make it accommodate more people. And so, and it's in the same manner. Here's our city layout, and right now it's made just for 25,000, but we can always add more stuff. So here's the general where everything is. We have 2 high schools, because we figured about, we looked at the population of Congo and realized about 8% of the population on average is in high school at any time, but that's just going to keep increasing with the way Congo has a very high growth rate in terms of population, so they have a lot of young people. And so for our population of 25,000, we should have a capacity for about 2,500 students, which we said would be 2 high schools. And when we go to 100,000, that would be 8 high schools. And so then we also decided to have 4 middle schools and 8 elementary schools. And so you can see middle schools are in green and elementary schools are in yellow. And they're kind of spread. If you look at the layout with the tram overlaps, you can see for convenience, things like schools and the library and other things that people would need to get to, more importantly, are right next to the system. And then also you can see housing will be mostly over here. Not exclusively, it'll still be intermixed with everything else, but just this area over here will be exclusively housing, whereas the rest of it will be mixed. And you can also see this wherever there's green is park space. One thing we noticed in the background was that there's a bit of beaches along the coast, and we wanted to have a lot of park space, so we have this green here, and then going all along the coast, and then this line is a road, and then we also, down here, we decided to have a big park. You can't see it, but it's kind of like a national park type thing. And so, what else? Yeah, and so when we expand to 100,000, we'll kind of expand everything in the same way. And there's the overlapped, and now to food sustainability.
Alright, the Congo, as a nation, is ideal for farming and crop production. And as you can see there, the 24% of children there are undernourished, and that's mainly due to the lack of government implementation for growing crops. So if we see here that the Congo itself has the agricultural potential to feed all of Africa, and that is 1.11 billion people, and that's only off of 281,000 square miles of farmland. Now, if we take the farmland in our nation, or in our city, we have 175 square miles, so that would be enough to feed each of our, well, that would be 7 times the amount we need, assuming that there's a constant caloric supply reaped per square mile for our people. And that's not including the fisheries that there already are on Lake Tumba So our people would have plenty of food to live comfortably, and this way our city will be self-sustainable, and there won't be any need to like import food from other cities or nations.
All right, so that wraps it up for our city. I hope we win this contract. As you can see, we've done a lot of research, and we like cities, and